Hello, this is Mrs. Ward, and I am going to go over the second half of the notes for section 10.5, Rotation of Conics. So this is the example that we stopped at. We have sketched the graph of the curve, and you have 4x squared plus 4xy plus y squared. So as soon as we see this middle term, this xy term, we know we're going to have to rotate our axes to eliminate that middle term, and we can graph them using the properties of conics that we learned in sections 1 through 4. So the first thing I'm going to do is I'm going to figure out how much I need to rotate my axes. So I'm going to use the formula cotangent of 2 theta is equal to my a minus my c over b. So remember, a is a coefficient of x squared, b is a coefficient of the xy term, and c is a coefficient of the y squared term. So in this case, I'm going to do 4 minus 1 over 4. If I reduce that, I'm going to have 3/4. So what I'm going to do is I'm going to use my calculator, and I'm going to do the inverse cotangent. So when I do that, I'm going to do the inverse cotangent of 3/4 is equal to 2 theta. Doing that on my calculator, this part will end up being 53.1 degrees, and that's equal to 2 theta. To find just 1 theta, I'm going to divide both sides by 2, and I'm going to find out that theta is equal to 26.6 degrees. So going down to my graph paper, I'm going to rough sketch about 26-degree angle. So remember, in trig, it's a positive rotation up, so this will be about my 26 degree. I'm going to do my best to make it perpendicular. And it may work, it may not, but I'm just doing my best. So here's my x and y axis, see the original one. This is my new x axis. This is my new y axis. So those are already done. That's my 26-degree rotation. Now the next thing we learned to do is we were going to replace our x and our y in our original equation with a new x and a new y in order to eliminate that xy term. And those formulas, remember, x is equal to x prime times the cosine of theta minus y prime sine theta. That's for the x, and the y is basically the same thing, x sine theta plus y prime cosine theta. So in order to do this, I'm going to go back up to where I have the cotangent of 2 theta is equal to 3/4 because I'm going to want to work with fractions instead of decimals because it makes it, I know you don't believe me, but it makes the work so much easier. So I'm going to draw a triangle for 2 theta because I know that 2 theta is the cotangent is equal to 3/4. Remember, that's adjacent over the opposite when I remember my trig functions. So if this is 2 theta here, the adjacent side would be 3, the opposite side would be 4. Completing the Pythagorean theorem, I'm going to get the hypotenuse to be 5, which means if I asked you what is the cosine of 2 theta, that would be adjacent over hypotenuse, which would be 3/5. I'm going to use these two formulas to find my sine and cosine of just 1 theta. So let's do sine first. So the sine, let's think of u as 2 theta divided by 2. Well, 2 theta divided by 2 will just give me the sine of theta, and that's what I want. Is going to equal 1 minus the cosine of theta, which we just said was 3/5, all over 2. So I'm going to think of that 1 as 5/5. So when I do that, I'm going to have the square root of 2/5, and when I divide it by 2, that's the same thing as multiplying by 1/2. The 2's will simplify. The square root of 1 is 1. The square root of 5 I'm going to leave as the square root of 5. And I'm not going to rationalize it because this is a work in progress. I'm going to leave it as 1 over the square root of 5. It's going to make my work a little bit easier when I'm doing these problems. Now I'm going to do the same thing for the cosine of 2 theta. So the cosine of 2 theta over 2, that will give me the cosine of theta. So that's going to be 1 plus 3/5 all over 2. Well, again, I'm going to replace that 1 with 5/5. 5/5. So when I add, I'll get 8/5. Dividing by 2, same thing as multiplying by 1/2. Here, the 8 and the 2 will simplify, and that'll give me 4/1. Square root of 4 is 2, and then the square root of 5. So the cosine of theta is going to equal 2 over the square root of 5. So when I go down here, I'm going to say x is equal to x prime. The cosine we just said was 2 over the square root of 5 minus y prime. The sine we said was 1 over the square root of 5. The y sine was 1 over the square root of 5. Cosine is 2 over the square root of 5. And to make my work a little bit easier to follow, I'm going to choose to drop the tick marks, the prime signs, knowing that these x and y's are going to be my new coordinate system, the one I just rotated. So I'm going to make this 2x minus y all over the square root of 5. And that's what I'm going to say x is equal to. I could have tick marks in there, but I'm going to drop them. It's just going to make my life a little bit easier. Y is going to equal x plus 2y over the square root of 5. So that's my x and that's my y. Remember, I'm going to resubstitute this in every place I saw an x up in my original equation. Every place I saw a y, I'm going to substitute in my y. So this is what it's going to look like. I had that 4, and then I had x squared. So I'm going to have 2x minus y over the square root of 5 squared plus 4x, that's my x, times my y, and my y is x plus 2y over the square root of 5. Then I want plus y squared and then I'm going to have minus 2 square roots of 5 times x plus 4 square roots of 5 times y. And then I have minus 30 is equal to 0, so I'm going to take the 30 over to the other side and say is equal to 30. Now I'm going to square it. So going to a new page for a second, I have 2x minus, well, my 4 is going to be 4. I'm not going to do anything with that. When I take the square root of 5 and I square it, my denominator is going to be 5. I just have to worry about squaring that numerator. So that numerator is 2x minus y. I want to square that. So I can either remember my formula a minus b squared, which was a squared minus 2ab plus b squared, or I can think of it as 2x minus y times 2x minus y. However you want to think about it to FOIL it correctly, that's what you need to do. So it'll end up being 4x squared minus 4xy plus y squared. That is going to be my numerator. So I'm going to put that on my numerator. So that'll be and that's all over 5 plus 4. Now I'm going to multiply the 2x minus y, 2x minus y times x plus 2y. There's no rules for this. I'm just going to have to FOIL. So this will be 2x squared minus xy plus 4xy minus 2y squared. Combining my like terms, I'm going to have 2x squared plus 3xy minus 2y squared. And that is going to be my numerator. Oopsie, that's a minus. And this is all over the square root of 5 times the square root of 5, which will just be 5. Now I'm going to square this x plus 2y. I'm squaring that, so I'm either doing the a squared plus, I'm doing a plus b squared and getting a squared plus 2ab plus b squared. So let's just do it that way. A would be x, so this will be x squared. When I multiply these two, I get 2x. Double that, and I get 4xy. And then 2y squared will be 4y squared. And that is my numerator. and then the square root of 5 times the square root of 5 will just be 5. Here, when I do these ones, I'm not raising the quantity of power. I am distributing this negative 2 times the square root of 5. The square root of 5s will simplify. So now I'm distributing a negative 2 times both of those. So this will be minus 4x, and then a negative times a negative will make that plus 2y. With this 4 times the square root of 5, the square root of 5s will simplify. Distributing the 4, I'm going to have plus 4x plus 8y, and this will still equal 30. Now everything's over, the first three terms, these first three terms, all over 5. So I'm just going to write them all once over 5. Here I'm distributing my 4. So I'm going to have 16x squared minus 16xy plus 4y squared. Doing the second 4 plus 8x squared plus 12xy minus 8y squared. Now there's no coefficient here, so I'm just copying down the numerator, or the numerator, x squared plus 4xy plus 4y squared, and then these all are over 5. Over here, when I have the ones that aren't over 5, I have negative 4x plus 4x, that'll equal 0. 2y plus 8y will be 10y, and it's still equal to 30. Make sure you know that that 10y is not over 5, that's over 1. Do not combine those somehow. Now I like to highlight. You probably can't highlight, but you're going to have to concentrate. I'm going to look for my xy terms first, because the whole reason for me creating that whole new x and the whole new y is to eliminate my xy terms. So I want to stop and make sure that I did eliminate my xy terms. So here I have negative 16xy plus 12xy plus 4xy. Well, the negative 16 plus 12 plus 4, that does equal 0. So I succeeded in eliminating that xy term. So good for me. Then I have, let's do the x squareds next. So I have 16x squared, 8x squared, 1x squared. So when I add those all up, I believe I get 25x squared. Now let's do the y's. I have 4y squared minus 8y squared plus 4y squared. And I'm doing a double check. Yes, that did end up equaling 0. The only thing I have left over 5 is this 25x squared is over 5. Then I had that plus 10y is equal to 30. 5x squared plus 10y is equal to 30. So that's my equation right now. And I want to, well, okay, so we're going to remember this, and I'm going to highlight this because the next notes I want to come back to this part where I got to here. So we're going to highlight this. This is what I first got. Now, when I look at this, remembering all the properties that I learned from 10.1 through 10.4, I realized that I only have an x squared, nothing else is squared, which means that my conic is going to be a parabola. So remember, when I have a parabola, I put whatever's squared on one side, everything else on the other side. So I'm going to write this as 5. Whoopsie, that's a real bad color choice. I'm going to write this as 5x squared is equal to negative 10y plus 30. Now, according to our formulas for a parabola, the coefficient of the x squared has to be 1. So I'm going to divide everything by 10. And when I do that, I get x squared is equal to negative 2y plus 6. Then, when we did conics, we factored out whatever the coefficient of this y was. So this will be negative 2 times the quantity of y minus 3. Now, it's a parabola. It does not have a center because it's a parabola. It has a vertex. The vertex is whatever I'm subtracting from x, which will be 0, whatever I'm subtracting from y, which will be 3. My p is equal to negative 2, which means p is equal to negative 1/2, which means my focus, oopsie, spelled focus wrong. My focus, my x coordinate is going to stay the same. My y coordinate is going to go down 1. So this will be 0 and then 2.5. Because remember, if the x is squared, that means my parabola is opening up or down. Since this coefficient is negative, it's going to open down. So what I have now is my vertex is on a normal thing is 0, 3, and then my focus will be there. So my parabola will look something like that. That is if it were on a normal XY plane, but it's coordinate system, but it's not. Remember, these are primes. We took out the primes. This is my X prime, Y prime, which means I have to graph on my X axis, my X prime axis, and my Y prime axis. So I'm going to pick up that you're just rotating your piece of paper. I'm going to make sure that I grab everything so everything comes with me. And I grab most of it, good enough. And I'm going to take this paper, and you're going to take your paper, and you're going to rotate it. It's not much of a rotation. It's only a 26-degree rotation. This, I'm going to make sure is horizontal. This should be vertical. That's about as best as it's going to look. I'm going to graph this parabola just like I would normally. So it's going to look like this guy here. So my vertex is at 0, 3, so I'm going to go up 3. My P is negative, so I know it opens down. My X is squared, so I know it either opens up or down. And I'm going to graph it like this. And that's going to be my graph normally, and that's what I had right here. But now remember, I rotated it, so my final answer is going to be when I rotate that paper back. So let me grab all this to the best of my ability. And I rotate this paper back so that the normal X, my regular X is horizontal, my regular Y is vertical, and this is what my graph should look like. So we'll graph that in the calculator in a second, but that's what it should look like. Then the next part of the notes talks about things that should never change from when I originally started to what I ended with. So let me go back here, and I am going to grab my original, whoopsie, too far. I'm going to grab this. This is my original equation, and I'm going to stick that here. So that was my original equation. I can make that smaller. And then I'm going to go grab the equation that I ended with. Remember how I said I wanted to stop at the 1 point? And I'm going to grab that. This guy right here. And so remember, we said that this was my normal XY right here. This is my normal XY, and then this is my X prime and my Y prime. So what this is saying is that when I rotate the axes, there are certain things that should not change, certain properties should not change. And one of them is my constant F. F should stay the same from my first equation to my second equation. My first equation, I had negative 30. Well, if I rewrote this as 5x squared plus 10y and set it equal to 0, like this one is, minus 30 is equal to 0. So that works. My 30s, both negative, that did not change. That's one way I can check and make sure that I did this right. The next thing is I take my A plus my C. So up here, my A plus my C, in this case, was 4 plus 1, and that equals 5. That should equal my A plus my C in my new equation. Well, remember the A is your coefficient of your x squared, which is 5. Then the C is the coefficient of the y squared. Well, I don't have a y squared, so that would be 0. So my sum is still 5. So that does check for me. And then the last thing that should happen is what's called the discriminant, b squared minus 4ac. You should recognize that from the quadratic formula when you first learned how to solve quadratic equations. So when I do my discriminant of the function, it should still be the same. So on this first one, on this equation here, switching colors, when I go to here, my b is 4. So this would be 4 squared minus 4. My a was 4. My c was 1. And when I got that, I got 16 minus 16, and I get 0. When I do it for my new equation, I'm going to do b squared. Well, the whole point of this was to eliminate that middle term, or the xy term. So my b squared should be 0 because I don't have an xy term. Minus 4. My a was 5, And then my c is my coefficient of my y squared, which is 0. So I'm going to end up with 0 minus 0. So my discriminant is still going to be 0. So those two match, so that works. Those are the three things, the ways that you can check to make sure after you did all this work, you didn't make a mistake. Those are the invariants, means that they do not change. They didn't change. They're the same. Last thing in this section is classifying conics by the discriminant. So that's where you're doing the b squared minus 4ac. So over here, we did the b squared minus 4ac of the original equation, this guy here, and we got 0. Well, when I look at my chart here, if the discriminant is equal to 0, it should be a parabola, and that's exactly what I ended up with. If the discriminant is less than 0, that means I have a circle or an ellipse. If my discriminant is greater than 0, that means I have a hyperbola. So let's do another one. So example 5, and I put this on for a reason. This is basically copied the word for word for what your homework has, and I can't remember the numbers, but on your homework sheet, it'll just have A. I think it's like 41A, 37A, whatever they are. You are just doing part A, and part A is classifying the graph of the equation. So I'm going to do 16 squared, no, b squared, sorry, b squared minus 4ac. So my b is 24, 4, my a is 16, my c is 9. I'm going to do that and see what I get. So when I do that, I get 0, which means this graph should be a parabola. The second part of the directions say use the quadratic formula to solve for y and use the graphing utility. We're not doing that. You're crossing those directions out. That's why you're only doing B. I do want you to graph it in your calculator, just one or two, just so you get practice graphing them. What you must do when you graph it is you must put a multiplication sign between this x and the y. If you don't, it's going to ask you to put in a slider because it's not reading the x and the y as two independent variables. It's reading it as one. So you need to make sure that you put x times y in your calculator. Remember, when we're doing these in relations. We're doing it in relations. So let's go back to the one that we just did. I'm going back to this guy right here from example, oh gosh, she's pages and pages ago. So this one from example 4. I'm going to pause my recording for a second, and I'm going to type that in and show you what I typed in, and then I want you to make sure that you're typing that in, and the graph that we should end up with on our calculator is that graph that we just drew there. So I'm hitting pause to graph, and you should be picking up your calculator and graphing as well. Okay, so I'm going to hit tab to show you what I typed in. Notice I'm in a relation. You have to be in a relation. I typed in exactly what I saw. 4x squared. I just typed in 4x squared. It put the multiplication sign in for me. I had to put in this multiplication sign for 4 times for the x times the y. Then I put in a multiplication sign for here. Make sure that that x is not underneath the radical. Make sure that this y is not underneath the radical. And when I did it, I made sure I was in standard view. And then this is what my graph looks like, which I think is a pretty good match to what we got here. So that's one way. So make sure you can graph one or two on your own. You don't have to graph all of them, but make sure that you know how to work your calculator. If your calculator is asking you for a slider, that means that you made some type of mistake. So go back and change it. All right, just checking a few more. This one, using the discriminant to find what it is. I got yeah, I did negative 4 squared minus 4ac, so I got 16 minus 24, and is not a hyperbola. I believe if it's negative, it's an ellipse or a circle. And we're going back to verify, less than 0, ellipse or a circle. So this one should be an ellipse or a circle. My other class got that wrong. So that should be an ellipse or a circle. I cannot tell whether it's an ellipse or a circle based on the discriminant. I'm just going to know that's one or the other. All right, so that's all you have to do for that. If you notice that your homework is here, this test will now be on Tuesday, I believe. And this is what's due on Wednesday, block 5, block 6. If you guys, this is just doing discriminants, I think you should be able to try them, but if you can't, don't, and I will plop them on the next days. All right, I hope this video helps, and we'll see you next time in class.